All right. It is time to start. We're going to get through this. After this is lunch, which is everyone's favorite presentation. Today we're more or less talking about the title of the talk. There might be some flexibility. There might be some tangents. There might be some movie stars involved in some of the slides. But in essence, we're going to be talking about trying to build our own little data set, the struggles, the eventual... Do you want to intro me?
Yes, I would.
Okay, great. Okay, sorry.
You've introduced yourself already. Just talk. Oh, let's start again. Okay. So, we're just going to like a discussion on the meetup. 2 months ago about your pet project. So, what about all these open, more or less open databases? And if you would be able to join them to enrich some research and find a few good answers. And then it turned out that it became a more serious project, right? Not still bad, but okay. Yeah. All right, so, Marcin, sorry, and stage yours.
Sure. Okay, thank you. All right, so let's just get into it. I'm Marcin Kraszewski. You can scan this to look at some really awful code. I have like 78 repositories. None of those are going to impress you, but if you really are into side project hell, go ahead and check out that repo. I originally designed that before AI was designing stuff. And actually, I don't remember what I was going for. It looks like a slice of pizza, but I think it's supposed to be something with a chart of, like a data analysis chart or something, I don't know. So these are the tools that went into this project. Now, Netflix, I'm not talking about the data set of Netflix. I'm not talking about any of that. I'm talking about that's what I had playing in the background. I had the movie Arrival with German dubbing, no subtitles. I don't speak German, but I've been to Germany several times in the last month, and I thought I would try to brush up on it while working on this project, so a little multitasking. Also, Google Docs, that's where the slides are living. Spotify, just in case Netflix was getting a little bit annoying, I was switching to some music. I was trying to do this all on my local GPU setup because I bought it and I have to use it for something. So I thought, why not for this entire presentation? I also used, oh yes I did, I used Gemini. Now I started off using Gemini, the free version. I don't know if any of you have used crack cocaine, I haven't, but I assume it's a lot like using AI for coding. So as much with drugs, it starts with free sample. Hey man, you're in a street corner, somebody comes up to you, hey man, hey. What if you could, what if you could just write def and the name of the function and hit enter? And it just writes it for you, man. Come on, try a little bit. So I tried Gemini free, and Gemini free was fine for a little bit. I ran out of tokens pretty quick. Let's try all kinds of stuff. So I had to upgrade to Plus, and I was really getting into it. I was locked in. I was like, yeah, this is great. This is going really wonderfully. Ran out of tokens. It told me, how about tomorrow at 9 in the morning? I said, how about here's some 48 zloty? And it unlocked the Pro. So I went really fast from free Plus to Pro. Other tools, VS Code, Python, some Neo4j, but probably just delicately touching our toes there a little bit. So, as you may have seen from the first slide, my name is Marcin. These are, I have a lot of sort of interest in names in general. Just the idea that you are represented by this string of characters. We're all represented by a string of characters. Some of our strings of characters are shorter, some are longer, some are more complex, some have more entropy, etc. But the idea here is these are names that are kind of somehow maybe similar to mine. Similarity is, there's different ways to measure it. Here's my last name, Kraszewski. One thing you may notice right away that you may have already done when you're looking at these little images here you probably said, Marcin, okay, Krzyzewski, okay. You're already generating some geographical coordinates. You're saying Poland. This guy has to be Polish, and you would be right. I was actually born in the capital in Warsaw. So that would be correct. So I don't know how many of you do that on a regular basis, but you probably do that just naturally. So when someone introduces themselves, there's a little program, a really simple little function that's called try to guess the person's national origin from their last name. We do it consciously, unconsciously, everybody does it. So that, again, I'm interested in the whole idea of like how much information is in just your name. Right? How much does it tell us about you? How much doesn't it tell us about you? If we have two names that are kind of look similar, are they actually similar like geographically or not? Is there any connection at all? Or is this just randomness? Should we all just be named after UUID numbers? So there's a website I really like called Forebears. And the way it works is you essentially put in a name. This is Krzyzewski. And this is the distribution of the name Krzyzewski. As you can see, there's Krzyzewskis in Poland, in Germany, in France, in the US, of course. There's some in Australia. There's some apparently in, help me out, Thailand? Is that Thailand? I hope that's Thailand. Okay. Anyway, in Southeast Asia, there's some Krzyzewskis there too. That's a pretty cool tool, but here's the thing about Forebears. I emailed the guy, because it's like a pretty small team. Or at least, I don't know, the guy responded to me pretty quickly, and I asked him about the platform, and he's like, we have like billions of records. And I said, well, can I get access to just the records, like just the raw data? And he's like, no, you can't. And I was like, yes! A challenge. Okay, so no, I'm not going to hack Forebears or anything, but I thought to myself, what would it take to clone something like this, or maybe not even clone, but just to kind of play out the idea of like, I have some names, I have some coordinates, where do I get the coordinates, where do I get the names, so what do I have to do here? Again, I'm into obviously family history research. Here's Krzyzewski, here's all the regions in Poland, it shows up. So here's in Ukraine, Krzyzewski, I translated using Google Translate. I guess that's Krzyzewski. I can read a little bit of Cyrillic, but it's mostly guesswork. So this is where the Krzyzewskis are today, more or less. And again, there's lots of other ways you can search for last names. You can go to Google Book Search. You can go to archive.org, look through books. But this is all kind of very not specific, not precise. Doesn't really tell me anything. Google Ngram Viewer. I don't know if you know Google Ngram Viewer. It's essentially a search tool where you can search through, and correct me if I'm wrong or email me later, all the words that Google has scanned and all the books that they've scanned. You can basically look at it. And the really cool thing here is, you've got time. So you've got a word and you've got time. Now what I'd like to do, I guess you could call that a double. I'm interested in like triples, where you have a name, a location at a time, then you can do some interesting stuff. And maybe quadruplets, which would be a name, a location, a time, and an event. We can dream. So can I roll my own? Can I roll my own is the question here today. And when I say my own, I mean using other people's data perhaps. But generally, like, can I get something to work? Okay, so here's what I need. Obviously, I need a data set. It should be publicly available. The license should be fairly flexible. And it should contain a lot of people's names. I've been doing brainstorming. I've been trying to think, like, where could I get data? Of course, there's something called Common Crawl you may have heard of, where it's an open source version of Google Crawl, sort of. Like, they have web crawlers that run. You can just publicly download what is something like 5 petabytes or something of data. So if you're completely insane and you want to collect every name in the world, this is what you would do. I tried it, but it just, let's just say it's a lot, but too much data to handle for me. Okay, so, God, there must be a website that has lots of names out there where the information is pretty accessible. Of course, we all know Wikipedia. When I started college, let's say, this was looked down upon to use it for anything. Now it's used. I still probably look down upon, but people use it. But as you can see, there's a bunch of names. There's a bunch of names. There's a bunch of people's names. And already, even just here in this people section, we can see a name. We can see a year. We can see Polish politicians. So Polish politician, maybe we can say, oh, that's probably in Poland. So we have name, we have time, we have a location. We don't have an event, but we have like triplets. So that's pretty cool. So if I was just going to create a tool from this, it would be pretty basic. But again, it would tell us something. It would tell us like Krzyzewski's probably Polish, and here's the years where it was held by a couple people. So I had to look for So I'm going to get started. I needed a data file, a database, something to just extract data from. I found this little file in Wiki latest pages, articles multi-stream, XML BZ2. It's a compressed XML file, and it is 20 gigabytes compressed and 119 gigabytes uncompressed. And again, you have to remember, I'm doing this really locally. I'm trying not to use any clouds, any PySpark, anything. I'm just trying to really do bare bones here. I'm just trying to do a POC here. How many non-unique person names can I expect to find? Now, this is going to be some embarrassingly bad math because I'm not a mathematician. If you are, just quietly after the talk, tell me how wrong I was. So what I did is I sampled 100 articles from Wikipedia, because I was in a hurry. And as you can see, 97 analyzed, so there must have been 3 maybe redirects. I found 1,611 person names, and I did this using Spacey. So of course I'm cheating, I'm going back and forth, I'm using different tools. But anyway, I've got that many names. And using really, really bad math, I'm estimating there are 705 million non-unique names, which means like names could appear hundreds of times, like Abraham Lincoln maybe appears hundreds of times in Wikipedia, but if we just count each one as an event or an entity, that would be 705 million. So it's a lot of names, even if this is off by a factor of 10, and it's just like 70 million, or even if it's 7 million, it's still a lot of names to deal with. So anyway, let's get into this here. So real quick, I don't want only to store a person's name. That would be useless. So I want location, I want date, I want events. All good stuff, all good stuff. Because eventually I want to be able to ask questions of this information, and I would, of course, we could always ask the AI, right? Just ask the AI, but the AI likes to make things up, so I like to have data from a database. Okay, I'll start out with building an ultra bare bones POC. Let's see what's possible. So one page attempting. So here's one page, trying to do it with one page. I've got, I chose this guy because I was kind of curious, because this stuff is going on with Donald Trump, and I just thought, I wonder how many, and I asked Gemini, I said, hey, Gemini, how many world leaders are actually imprisoned right now? And this is one of those world leaders that is in prison for some crime. I can't remember what he did, but he's in prison, and I just thought that'd be kind of a cool thing to do. So, yeah. I apparently exceeded my Gemini quota. I'm not sure why or what happened, but this is just, it's just the idea that I was trying to be smart, I was trying to be slick, and I said, hey, I'm just going to feed this Wikipedia article. It's probably like the equivalent of 11 pages or something. I'll just feed it in, it'll go look at context, it'll do all kinds of wonderful things to try to extract these triplets or these quadruplets, and I ran out of the tokens, so I was like, that's pretty disappointing. As you can see, something there. Okay, so I dropped the LLM features altogether, focus on a simple solution that uses only Spacey. So Spacey is a library. Now it uses large language model. It's confusing, but anyway. So basically, Spacey is a tool that you can just, it's a library, you can plug it into your project, and you can say, find me all the people's names or geographic things, or basically named entity recognition is what it does. It's really good at that. It does all kinds of other things too, but that's the most thing, I think that's what it's most famous for. So I managed to gather about 34 entities from that demo page. I created a simple plot. This plot is horrendously ugly. It tells us nothing. But again, I'm trying to go towards some direction here. So as I'm developing this code, I did have this sort of epiphany where Wikipedia has a lot of different sort of types of data. So it has raw text, it has tables, it has bullet lists, and it has info boxes. And each of those, because it's Wikipedia, because it's edited by everybody, you can have tables that are all kinds of craziness and all kinds of different things can happen. So I thought, hey, I want to use, let's try to use LLMs, but really just, not just locally, but just give them a little tiny bit of data. Try to just see if they can squeeze some usefulness out of these things. And so there's a function called isPeopleTable. And what it does is it sends a little, 2 rows of the data frame that's been created after parsing the wiki markup and all this stuff, and it sends it to the LLM, and it just asks the LLM, look at the headings, look at the columns. Would you say that in this table, each row represents an individual person? So that worked pretty well, except it took something like 17 seconds, I think, just for the first result to get created. And this is running locally. Obviously, I could scale this and all this stuff. But I realized that I had a bit of a problem. Again, I apologize about the math. But 17 seconds per table, let's say there's 100, let's just say there's 100,000 tables in Wikipedia. I bet there's like millions, but there's 100,000 tables. We're talking about 466 hours of doing this. On my machine, I scale it up to the cloud. I'm spending hundreds or maybe thousands of dollars, whatever. It's just not worth it. So I found a file which has 8.6 million records, sorry. I go to Gemini. I say, help me. Gemini says, I will oblige. And Gemini created something. So here I got this far where I'm feeding it into Neo4j. I'm trying to create a graph database. And it's taken a while because this isn't a cluster, it's a gaming computer. Let's just say it's a gaming computer. And it's just taking a while, so I start getting a little bit distracted. I just start thinking about like geography, biography, birth dates, and I think about, how old is Ryan Gosling right now? And it turns out Ryan Gosling is older than I am. So I feel pretty good about that. I feel pretty good that Gosling is older than I am by about a month. So I got you, Gosling. Yeah. So it finally finished. After my tangent, I actually visited like dozens of sites while trying to complete this project. I was a little distracted by the internet. So this is the garbage site I came up with just as a demo, Biograph Explorer. So the idea generally was I wanted to build something where I could say, where did most people, let's say with the family name Krzyzewski live? I even misspelled my own last name there somehow, or the year I did, or whatever. But anyway, translating the graph query. Oh, no problem. This is what happens when you go a little too crazy, too deep with the AI coding. So this was a whole problem, and I said, okay, I'm just going to copy-paste it into Neo4j running on my desktop, and there we go. So for Krzyzewski, so we've got a proof of concept, like proof of a concept. When Krzyzewski tells us Poland, Russian Empire, crown of the Kingdom of Poland. So this is technically, this is technically done, but let's just continue here. So I have this other file that has, I can't remember, 30,000, it has 30,000 or so cities, locations, villages, everything. And there's a lot of do you even realize how many settlements there are on Earth? It's something like a couple million, which is weird. I don't, like, where do they all fit? It's a lot. It's a lot. There's a lot of people living in a lot of places. So I tried some things. But at the end of the day, really what I was trying to do, I wasn't really trying to create a slick service or anything. I just really am kind of like deep down, I want to know how many person names are there in the entire Wikipedia English dump. I just want to know how many people are in there. Not how many people have articles. That's a different, it's like a hierarchy, right? So if you're super notorious, you have notoriety, you're famous, right? You get to have an article. But the everyday Joe that's like the guy that, let's say you're Abraham Lincoln's, I don't know, butler, and maybe you're mentioned by name like Jeff. And it's just Jeff. We don't know anything else. It's just Jeff. Well, we forget about that because he doesn't have an article. So I want to find those people's names. I want to find them all and collect them. So I found another data set, which I really like. It is the cross-verified database. This is actually really nice. This is I wish I would have created this myself. This is a data set created by scientists, and they did extensive cleanup and everything of it. You just download it, and so it's got 2.2 million names, not 700 million. So I mean, obviously these are probably unique names, but there's 8 billion people on Earth. There's got to be a lot more names than 2 million. So here's an idea. Let's just really go old-fashioned. Let's just, because we got this AI here, we got these tokens, we got the pro account. Let's just grow. Let's just go regex. Why not? Okay, we haven't burned down the house yet. Let's do regex. So I'm trying to train a regex here using some data. Of course, it's not working here. So I go to Claude, which is the competitor to Gemini. I say, Claude, this other model, it sucks. It's not like you. You're the best. I need military grade. Military grade. Claude's like, yes, I will give you military grade. Okay, so then the military grade, when I run it, and I feed it back, it says, you got data leakage, you got overfitting. We don't want overfitting. If your model's overfitting, it's It's just looking up, it's like a lookup table. It's saying Thomas is in the table, so Thomas is a match. Yay, no generalization at all. It's completely useless. Okay, so let's see, hold on one second. So what I end up trying to do is I'm like, okay, all right, let's try to forget about regex. Come on, let's just throw some spaghetti at the wall, see what sticks. Let's just do some machine learning. Let's train our own model. Oh, yes. There is something called Spacey. I already mentioned it, so why don't I just use Spacey, of course? Because AI is a drug. Okay, using Wikipedia archive. So here's what I said. I said, fetch an article, use Spacey. Let's compare the model I trained to Spacey, developed by teams of people. Let's see. All right, so there's a more training. I trained 200 trees here. It's this. Wow. Don't have a lot of time for that. Okay. But I'm training on a ThinkPad that's 7 years old. So here's something interesting. Spacey apparently thinks Sessions House is a person, but my model doesn't. So sure, my model at the bottom makes a bunch of mistakes, but still Spacey, this cutting edge model, thinks Sessions House is a name. It also thinks official website and Bratislava are names. It thinks Corey is a name, which is correct, obviously Corey. But as you can see, like, Spacey thinks wooden churches is a name. So even this really great model, I'm using the small version of this big. There's all kinds of things you can do. But my point is just, I kind of cranked this out of nowhere, and even the best model is making really, really dumb mistakes. I mean, like wooden churches is, maybe there's a guy, we don't know, right? There could be a guy in Tanzania named Wooden Churches, and that's his name, and that's who he is. That's possible, I guess, yeah. Just a second, sorry. So there is an ultimate way to extract names from raw text. Ultimate. I discovered it. You may know it. It's very fast, extremely fast, and quite precise, but has only a very narrow use case. This is going to fetch all those Polish EFSCI names. I can run this tonight on Wikipedia. I can do a full report for you how many EFSCIs I found. This is cutting edge. This is state of the art right here. Questions? I can go through some code and stuff, but I don't. How much time do we have? 35 minutes still, yeah.
No, you consume some of them.
Sorry?
You consume some. Still 10 minutes.
Still 10 minutes. Okay. Let's see. This is kind of scary. Okay. Oh wow. Now you're going to see really scary things. This is my notebook, and this is my VS Code. And who would like to try to run another article and see if Spacey can compete with my model? Anybody? Let's try it. Let's see if it works. I don't know if it's set up correctly or whatever. It's going to crash. Okay, the article is Volcano class logistics support ship. And apparently Spacey thinks Fincantieri could be named Jacques. It's doing pretty good. So Spacey totally beat my model here. But Durance, I could see Durance as a name, Defessa as a name, maybe Castellamare, it sounds like a name. And if you want to see what the code looks like, there's, what would be an interesting, let's see, here's, just a second. There's a lot of code here. There's more code than needs to exist for this. I came to the conclusion that trying to grow your own regex, even with a lot of examples, I think I had 1 million examples or something, it just doesn't make any sense. We're in 2025. So, it's sort of like you're trying to not use LLMs, but they're just so nice to use, and they're always so there and available. And when you try to go against them and you try to say, hey, I'm going to build my own thing, don't stand in my way. The other problem is libraries exist. There's so much that already exists. It's so hard to come up with a project that you can do that doesn't exist unless you're maybe building, I don't know, it's hardware or something. But in general, dealing with raw text, dealing with text, trying to clean it up, the only thing we can really say is that it's sort of a problem, because if you use LLMs for this, even if you spend the money, you're still going to have some data that's in there that you're still going to have some things that aren't names. This is like a very long, like the tail of problems you're going to run into with names, like real specific little tiny edge cases, kind of go on forever. So, and there's people that had, let's say they exist, one person, they have that name, they're never recorded, or there's some family history or something, somebody passes it down incorrectly. There's just so much noise in names, and there's so little information that we can get from them, that I'm afraid that just because someone tells you their name, you can assume that they're German probably, or they're Polish probably, or they're Bai Chinese or something like that. You have to remember that when you look at a family tree, every generation you go back, it sort of like, it doubles, right? So you have like two parents, 4 grandparents, et cetera, et cetera, et cetera. If you go back really far, let's say you have, hundreds of relatives, just one of those people is passing you the surname. So just because your name, let's say, is Khrushchevsky, you could have, that one guy, like the surname passes, but they're like, all these other people have nothing to do with that surname at all. So half of our parents' name, then we take from, usually we take from one parent the name. It's kind of a silly algorithm, right? It's very greedy, because it basically tells us that, it tells us, oh, half my ancestry or whatever is from this last name, but actually it's like just a very tiny part. So I think better than names, just to kind of transition, is if you have any of interest in this sort of topic of names and connectedness and geography and all this, and you're not too afraid of privacy issues, I would suggest a DNA test. I took one. I realized I should have a lot. My last name should be a lot more diverse. There should be some maybe singular characters. Maybe there could be a couple Hebrew letters. I don't know. Like they're just. I am like Rzeczpospolita too. Okay, so like whatever Poland was between the world wars, that's like my genetic makeup. Like I'm from all over that map. So just because someone tells you their name, don't assume anything, even though your brain, it's so hungry to just classify the person. It's really not at all accurate or precise. And unfortunately, people do put weight onto it. Some people put a lot of weight onto their surname, their last name. But like I said with this example, it's something that is so very fragile based on who's passing it down, that I think maybe if you are interested, probably research all the other, last names and surnames and stuff. And this is kind of where this came from, was trying to find out all these different combinations that you could possibly extract. Okay, so thank you. And I guess that's it. No questions at all? Okay.
Questions? Do you have any questions? Details maybe, or?
No. They're waiting for lunch. Very patiently, though.
I just still want to go. Presentation.
Huh?
Still one presentation to go before lunch.
No. I mean, we can go to lunch now if you want. Yeah.
Okay. Anyway. Thanks much for your presentation.
Thank you.
And see you next meetup, right?
Yes. Thank you.